Okay. So now, if you want to use iterative procedure, trial and error, you can start, for example, with a discount rate of 10%. You do the calculation, you replace I by 0.1, you get a positive value for NPV. Since you got a positive value for NPV, this means that the internal rate of return is larger than 10%. Okay, so you can try, for example, now a 12%. For 12%, you get a negative value. So you can be sure that your discount rate is your internal rate of return is between 10 and 12%. If you evaluate at 11, you are very close to zero. Okay, so now you can just do some interpolation if you want between 11 and 12 to get the value of your internal rate of return. Okay, and if you solve on your calculator, you will get a very close value to this one. Now, we'll repeat the same procedure for project B. So we'll set to get the internal rate of return of project B, we'll set the NPV at year 8 to 0, and also our only unknown is I. So if we solve, we get a value of IRR larger, that is 15.2%, which is larger than the IRR of project A. So we can deduce from our analysis that both factors are in favor of project B. Project B has a larger internal rate of return and has a larger CER, so we'll opt for project B. Okay. Now, as we discussed before, in case sometimes in some particular scenarios, we can have contradictory results. This means that, for example, if IRR of B smaller than IRR of A, but CER of B larger than CER of A, then in general, we base our decision on CER. Except if CER values are really close, but we have more large difference for IRR, we might say because CER are close, let me take the largest IRR. Okay, so in case you have critical values, you might change your opinion. Okay, but in general, in majority of cases, the two parameters will be in favor of the same project. Okay, now, in the third question, we want to compare the discounted and non-discounted payback period of project A, considering a discount rate of 5% and a selling price of $4 per item. And we want to comment on the obtained results. So now, going back to project A, okay, we want to compare, as they asked for, the discounted and non-discounted payback period. Now, you know that the non-discounted payback period is not very accurate because it doesn't take into effect the time value of money. But sometimes it's a tool that can help us if you want to have a quick estimation if the payback period is relatively long or not. You know what I mean by this? Consider, for example, a project. If I calculate the non-discounted payback period and already I get a value that is large, relative to the lifetime. So here the lifetime is 8 years. Okay. If I obtain a payback period of 6 years, non-discounted payback period of 6 years, this is an indication that the project is not very attractive because we know that the discounted payback period will always be larger, okay, always larger than the non-discounted payback period. So in case already the non-discounted payback period is high, we can say that the project has some problems. Okay, that's why it's true that the non-discounted payback period is not accurate because it doesn't take into account the time value of money with the change, but it can be an indication, tell us that the project is attractive. While if it's high, okay, this might indicate that the economic or financial state of the project is not very good. Okay, so, and to calculate the non-discounted payback period, please pay attention, you don't use the formula of before, because in the formula before you are dividing by 1 plus a to the power I, and when you do the geometric expansion, you have I in the denominator. You cannot have 0 here. Okay, so you don't go back to this equation when you want to calculate the non-discounted payback period. You just do a very small, a very simple analysis. Okay, you know that how you get the payback period. What do you mean by the payback period? You are searching for the number of years, okay, in order to have an NPV equal to 0. Okay, so now you need to write the equation of the NPV, but you don't consider the discounted values, and you don't divide your income and cost by 1 plus a to the power I. So you can just say that to calculate the non-discounted payback period, I consider NPV at year n, and n is to be determined here. Okay, your unknown is the number of years, but of course here they should give you the discount rate. So for a discount rate, here you don't need the discount rate for the non-discounted payback period. You need it for the discounted payback period. So here your only parameter will be for the non-discounted payback period. Your only parameter is n, and you say that of course I have first minus I. But here, since I don't have to take the value, the discounted value of money with time, I just add plus summation from year 1 to 8 of, sorry, from year 1 to n, because I want to search for n, okay? So from year 1 to n of Ri minus Ci. And here, do I consider the salvage value in my equation? Should I consider the salvage value here? We said that the salvage value is always we always take it at the end of lifetime. So here, since we didn't, sorry, do you hear me again now?
Yes. Yes.
Okay. Okay, so we're saying that whenever we want to calculate the payback period, we don't include the salvage value in this equation, because the salvage value, we account for it only at the end of lifetime. Okay, so this is a very simple equation that we need to solve to find the payback period. Okay, so we say it's equal to 0 is equal to minus 20,000. And since Ri minus Ci is constant with years, so I just can take it outside of the summation. And then I just have to say it's a plus the number of years Dear students, do you hear me?